Well, howdy pre-apes, and welcome to Chem 1 with Mr. Dawkin. We're going to talk about the development of the periodic table and some periodic trends. This is Unit 4, I believe Chapter 6 of your textbook. Pick up your pencils, let's get to it. The first thing that we needed to do was find some way to organize the periodic table. So there's a man in 1870s who devised a way of organizing the elements that they knew about into rows, groups, categories. The man's name was Dmitri Mendeleev. He constructed the first table by listing the elements in order of increasing, and I'd like you to box this in, increasing atomic mass. And then he arranged them according to similarities in their properties. There were elements that did not exist or weren't discovered yet, and he was able to predict the physical and chemical properties of those missing elements. So he was very ahead of his time. Later on, 1913, Henry Moseley, who was a British physicist, perfected the periodic table by arranging them by, not mass, go ahead and box that in. Moseley arranged it by atomic number, which is the number of protons, which is how we get the modern periodic table. So if you check out my periodic table on the wall, that is Moseley's table. Not Mendeleev's, that's Moseley's table. The one we see on shirts and shower curtains and all over the place. So we have this nice organized table now, and it fits really nice. There are other ways to rearrange the table, but this one works out pretty well. So here on out, there's going to be a couple of things that mention flipbooks and coloring and labeling. We're going to hold off on that today. Really, what I want you guys to accomplish is filling in your notes. And then at the end of class, I'm going to give you time to work on any sort of classwork that you may have in a different class. Okay. Test grades will be shared when I get back on Wednesday. So just hang tight for that. You may check the grade book today. Grades will be going in at some point today. Okay, back to it. Periods are horizontal rows. So if you'd like to draw a left and right arrow, they're going to be the left and right groupings, the rows, the periods. So it says label. We're not going to do that today. Periodic law, when the elements are arranged in order of increasing atomic number, which is how Moseley did it, there's a periodic repetition of physical and chemical properties, which leads to the grouping of the up and down columns, which we call groups or, and I want you to box this in, families. The vertical columns on the periodic table. Elements in the same vertical column have similar properties. Each group is identified by a number and a letter, A or B. Some versions of the table use numbers 1 through 18 for the groups rather than having A and B. The ones that we're going to see most frequently will have these Roman numerals, and I'm going to point out 1A and 2A, and it jumps the transitions to 3A, 4A, 5A, 6A, 7A, and then it says 0. However, I do like 8A, and I think we have 8A on our tables. But then you go back down, and you have these Roman numerals. You have a letter and a number. So let's classify the elements. Those groups or families have names, and I want you guys to know the names of those. We called those in group A, the A, so I'll write them up here, A. It'll be 1A, 2A, and then it goes A, all the way across to the noble gases. Those are the representative elements, group 1A through 8A. The one in red here, the first group, are called the alkali metals, and we're going to color those in when I get back on Wednesday, so just hang tight there. But they're extreme on the far left column. I want you to write in that they're very reactive with water. The alkaline earth metals, group 2A, that's the next column over. Those guys, I want you to write that they form salts. and not the kind of salts that you think of like on the table, but they form salts generally with some sort of halogen or some element from the group that oxygen's a part of. The halogens, group 7A, may be the most reactive overall. They are short 1 electron in their outermost energy level, and they like to get that electron, so that makes them very reactive. And then you have the noble gases, which you guys are pretty familiar with. Far right, group 8A, they are inert. They're completely filled, so they're quite the opposite of the halogens, but they're only one group over. So those are the families. Let me go back real quick. I'd like you to note that these families here have names. This would be the boron group. This is the carbon group, the nitrogen group, and the oxygen group. We just name them according to what element's on top. Nothing special there. The noble gases, like I mentioned earlier, have completely filled shells of electrons, similar electronic structures. So I'm going to go ahead and put these up. You'll notice that if you look in the highest energy level, so for helium it's 1, for neon we're in the 2nd energy level, argon we're in the 3rd energy level, and then I want you to look at, there is an exception with that 3D stuck in the middle there, but look, everything is completely filled in the outermost or the farthest out energy level. This is what makes them noble. They don't react with anything because they have no more room. There's no more room left for anything to fill in those orbitals. And then we have group B elements. You guys probably know that they're called the transition metals. They're the ones here in the middle of the chart that have the number and the letter B, called the group B elements. The transitions are where the D block was, and the inner transitions are going to be down here in where the F block was. We call them the rare earth elements or the inner transition metals. We're going to classify the elements based on whether they behave like a metal, a nonmetal, or something called a metalloid. The metals are found on the far left side of the periodic table except for hydrogen. Hydrogen is a nonmetal. Metals have high electrical conductivity. That includes heat. They have high luster. That means they are shiny. Ductile. They can be drawn into, and I want you to write this in, they can be drawn into wires. And then malleable means they can be bent. Most elements, and you can see by all the green there, are about 80% are metals. All of them are solids except one, and that is mercury, Hg. That is a liquid at room temperature. Nonmetals are going to be on the far right-hand side of the table. They are non-lustrous. They're not shiny. They're poor conductors of electricity and heat, if you want to add it. They may be gases, solids, or liquids. We have all three. Bromine is the only liquid at room temperature, Br. So on my table, it's the blue letters. And then we have metalloids, or what we call semimetals. They behave like metals and like nonmetals. They are in between. So I'd like you, well, not today, but I want you to note where the staircase is here, and you'll see that the metalloids follow this staircase. And there's one that actually doesn't really follow it, and that would be aluminum. It's on the staircase, but it's a true metal. And there's one more here, At, that's touching the staircase but doesn't actually behave like a metalloid. We're going to stop there. So what I'd like you guys to do is make sure all your notes are filled in. Go back in the video if you need to. I would like you guys to use the rest of class, plug in some earbuds if you'd like, work with a partner if you have classwork from another class. Make sure you're not being too disruptive, and get some stuff done. Okay, use it as a study time. All right, we're in a new unit here, not the most complicated stuff, but I want to give you guys some time to finish any assignments that you might need to get caught up on. Okay, that is all from Dockin. Have fun. Treat the sub with respect. I will see you guys on Wednesday. Ciao.